Hello, Glenn. Mike Kentrianakis here is Dr. Glenn Schneider at the University of Arizona, calling me, discussing about eFlights that will be available for next year's eclipse down in South America and over the Pacific Ocean. And also, I'd like to talk to him about the flights that occurred this 2017 in the United States, and also our 2016 flight, which had a viral video and it became quite the news back in March 8th here in the on the Western Hemisphere of 2016. So without much further ado, Glenn Schneider, hello, can you hear me?
Hey, Mike. Good. How are you doing?
All right, I'm fine. I'm so glad you're able to call and we can discuss this stuff because I think it's something that people would want to know, and I think it's a great option that flights are available, especially when it comes to remote locales. And this is something that you've been doing for, well, how many years have you been doing this, Glenn?
Well, the first eclipse flight that I did was in 1986, which was actually on a small aircraft. It was a Citation 2 between Iceland and Greenland. And after having done that, that was an extremely challenging eclipse to do by air. It sort of got my feet wet, though, and made me realize that there's lots of good opportunities for specific eclipses that are good to do by air for quite a number of different reasons. So I date back to 1986, October 3rd.
Okay, that is a pretty much unique, famous eclipse. I know there's been some controversy about it, whether Totality was there and such, because it just barely touched the Earth, or it touched the atmosphere. It didn't touch the Earth, but I know I've heard a lot about that, and in the people that we commonly know discussing it, and it's quite interesting. Nevertheless, it must have been truly a spectacular experience because I know it's something I would enjoy to see, something like a chromospheric eclipse where it just barely matches. And the closest I got to that was on May 10th, 1984, where I had 11 seconds. I was going for the 9 in St. Petersburg, Virginia, but because of cloudy weather, we moved to Greensboro, South Carolina on a 3-hour drive on I-84, 85, I can't remember. And we got clear skies and we had 11 seconds over there. And
You weren't far. Yeah, you weren't far from where I ended. They actually ended up for the same eclipse, which was right near Clemson, outside of Greenville.
oh,
So
okay.
sounds like we were not too far from
We
each other for
probably
that
were.
one.
Yes, we probably were not. Yes. So that eclipse. I mean, to compare that eclipse with October '86, it's. I mean, the question of closeness is not really the appropriate term.
It was a very different event. I really should put 1986 in a class of itself. It was controversial. I wouldn't say it's controversial. It has gotten us to really rethink time and again how we define things that are so marginal. And I think the thing to realize with 1986 is that the classical predictions at the time put it as a 0-second duration eclipse, and I think the only thing that's sort of controversial is if that makes any sense at all. It's sort of a discontinuity. It's better to think of the path or the path of totality ceasing to exist for a very short interval rather than being of 0-second duration. Now that may sound like angels dancing on the head of a pin, but it actually makes a difference phenomenologically. So what we actually saw was an eclipse where the apex of the umbral shadow at sea level just barely touched the ground. It was actually above the ground a little bit. So doing that one from an airplane at 44,000 feet actually got us about 70 or 80 miles closer to the moon because the geometry was such that the shadow was coming in at a near glancing angle. So we kind of go downstream a little bit, grew the diameter of the moon by zero point 0.7 arc seconds, by a small amount, but made it bigger by 0.03%. Now, that didn't give us what some people might call totality. I don't really know what you call this. We had a complete chromospheric ring, but it was punctuated at every fraction of a second with little Bailey's beads around the edge that were constantly in motion. And that was different than the eclipse that you just spoke of, the 1984 eclipse, which to me was more of a broken annular eclipse. We didn't have that complete ring of chromosphere, and I think that was the thing that was unique about 1986. So it's a question of degrees, and probably the October '86 eclipse was the closest that you actually could get to a 0-second duration eclipse, if you think of it that way, phenomenologically.
Right, and actually, it might be quite impossible to do so, or at least try to compute that to get zero duration? Because the question now is in defining the terms of totality. Is Bailey's beads, if they are there, are we at totality? They're such tiny points of light that are from the chromosphere. So, does it have to be fully extinguished? Because if they're fully extinguished and you've got deep valleys, and just that one comes through, you're going to cover some chromosphere too. You're not going to get all chromosphere because of it's not a smooth limb profile of the moon. So where is that point? It's a bit of a twilight zone there. So I think that in what you're saying,
it is, and this is sort of the more contemporary thinking, I believe, is that you don't transition directly from an annular eclipse to a total eclipse. When you look along the path in an eclipse like this, it's annular apart, and then the path where it's annular gets thinner and thinner and thinner. And then you traditionally sort of think that it flips and becomes total, but it doesn't. There becomes sort of a gray area in between. And if you demand this as a definition of totality, the total extinction of every piece of the photosphere, then you're right. You're sort of oversizing that a bit, because you get into this regime where it's not really black and white, so to speak. It really depends upon the profile, and it digs deeper in one place than it does another. So, the sort of traditional definitions don't hold. And again, we're sort of in this nebulous area, and you can compute whether or not you have a total extinction of the photosphere. That you can do pretty well today with the limb profile data that we have, at least within the current uncertainties. But phenomenologically, what you see is very different. And then let me just say, in the 1986 eclipse, for example, even though we saw little bits of Bailey's beads in constant motion around the edge of the sun, embedded in chromosphere, we actually saw beneath us, we were at 40 some odd thousand feet, and the altitude of the clouds below us was at 12,000 feet, and acted as a projection screen. And we could see the umbra projected below us, very narrow, squashed, cigar-like shaped umbra on the cloud tops. And we could see the umbra. It was quite clear that it formed and it was there, even though at the same time we were seeing Bailey's beads. And if you do the ray tracing, you can kind of figure out what's going on. But the two observations almost seem somewhat in discord with each other. The existence of the umbra, yet the fact you didn't completely extinguish the photosphere. So it's those irregularities at the very edge of the moon that sort of made the difference in those two eclipses. But 1986 was the real extreme one. 1984 was a clearer case, at least for me, as being a broken annular eclipse. I mean, there was always pieces of a photospheric annulus that were broken up, rather than the chromosphere being broken up.
Right. I remember seeing corona. I actually looked up on my eyes and I saw corona, inner corona.
Oh, yeah, no, you definitely could. I mean, an old eclipse chaser's trick, which I would never recommend to somebody who hasn't seen eclipse before, is using the thumb coronagraph, right? When you have the moon doing most of the work and you have just a little bit left of the photosphere, you can, at arm's length, stick up your thumb, block the photosphere, and you can see corona for a good minute or so before or after the contact 2 or contact 3.
Wow.
So you can extend your look at that, but you got to be careful, of course, not to look at the photosphere in doing that.
But I do recall seeing it, so I actually count that as one of my, well, not total eclipses, but as a coronal seeing eclipse. So it adds one to my list of official totals, 11. So that would be 12.
I actually have on my website, since you're comparing those two eclipses, if you go to my website and you dig up the 86 eclipse or the annular we're talking about, I have sort of a side-by-side comparison where I sort of split the photographs in half, so to speak, comparing half of one eclipse to the other side half of the other eclipse. And you can really see what the difference in the profile looks like between the two in terms of the chromosphere versus the broken photosphere. So it's apparent when you actually look at them side by side, but of course you never have that opportunity when you're viewing one in real time.
Are both these eclipses unique in our lifetime, in that there may not be repeat similar ones anywhere in the near future, or have there been in the distant past?
Well, this one is a little different from the fact that the 86 eclipse was a little different, and that the apex of the lunar shadow came within prediction uncertainties at the time, directly into almost a geometrical point at the surface of the Earth, which is why it was predicted to be 0 seconds. On any annular total eclipse, you can position yourself at a point where it transitions between annular and total and see something that's similar phenomenologically. So in that sense, it was not unique in what you might be able to see, but it was unique in our lifetime in terms of the actual geometry.
Hmm. Glenn, can you explain something to me? What is the difference between a 0 second eclipse and a no duration eclipse?
Yeah, there's been a lot of discussion about this recently. I think again, it is almost a philosophical point. It's a question of, can you actually compute the duration of the eclipse? Does it make sense to even talk about sort of the continuity of something that's defined by the tangential trace of a shadow when that ceases to exist? So 0 seconds almost doesn't make sense on its kind of a geometrical definition, but it sort of makes sense in the fact that that's how long you're not seeing the chromosphere, for example, in part, but it's in a transitional region. So, a non-existing umbra, which is really the question of, does the umbra exist or not? If the umbra does not exist, then you really can't talk about the duration of the eclipse at that point.
Okay. So that's where the difference is. You cannot talk about it, so it becomes no duration then?
And this is a relatively new concept that a lot of people have been talking about. Not a lot of people, but a number of people have been discussing recently. What's really the best way to talk about it? I mean, do you really talk about this sort of, instantaneous degeneracy as being 0 seconds in the umbra if the umbra fails to form? All right. I mean, if the umbra, from a geometrical definition of a connection of points which form vertices, fails to form, can you actually talk about a duration?
Wow. Okay. I think it's not something you can easily grasp until you're actually working with it. Maybe even doing
if
the
you
math.
looked at pictures and diagrams, it'd help a whole lot. It's hard to do abstractly on the phone.
Okay. Well, let's move on to, I guess, you've done, of course, many others since the '86, I believe, at least up until 2016, where it was my first eFlight Eclipse. So
Right.
I know you've done a number of those, and maybe maybe we could skip those, but let's talk a little bit about 2016. I just released yesterday the cockpit video of that flight on YouTube, and I'll put a link here in this podcast when I post it so people can see that. But that was really some flight for me. I mean, completely perfectly executed, this perpendicular angle. I mean, I never saw such precision where man was trying to be its own clockwork amongst the stars in the heavens, and it was this celestial synchronization of clocks, us doing it by will and it doing it by the forces of nature, and which was going to do it. We know they're not going to change because they're so heavenly bodies, as so big as they are, and so we had to. And I just remember exactly 2:15 wheels were up, and we were quite worried that there would be snow, and then from there it was a bit of relaxation until first contact came. But what was so spectacular, I mean, I have no experience with flying and seeing eclipses, but that I had this like perfect frame where it was, I guess the sun was at this right altitude, and the shadow came directly from underneath from it. It was really like watching this on TV, but live 3D TV. It was just perfectly framed, very comfortable. No, it blew me away, and the contrast and the sharpness, the colors. I can't explain it, but except if you see my viral video, you hear me actually losing it. But as 5 million people saw. But explain a little bit about that, because I remember we had the night before, we had a dinner with the pilot and the first officer, and we were discussing. He pulled out all the plans, and it was all talk about you and what you had done and such. And I know Joe was quite on top of it, and I did get a copy of it, but I never really got to pour over it to see exactly what was happening and what needed to be done, and how could you make adjustments for things. How do they know? Are we behind? Do we go forward? I mean, it's like, I guess it's like going to the moon in some ways. Maybe not so much, but can you explain a little bit about that history?
Yeah, 2016 eclipse was a little bit unusual for me in the sense that I was committed to be in Indonesia and I was on the ground. I was not actually on the aircraft. I mean, I do planning for other people doing flights. And this was a rather unusual one in the sense that this was, as you well know, this was not actually a dedicated eclipse flight per se. It was actually a commercially scheduled flight that, with contact and discussions with Alaska Airlines, that was incredibly cooperative. They changed the takeoff time for the flight in order to enable getting into the lunar shadow just at the right time. But we're very, very cooperative. And I was doing updates on a daily basis based on predicted winds and such right up until the event in Indonesia, and then sending that to Brian Holm, who was the captain for the flight, and making adjustments. And I think you guys know that you actually had winds aloft of 145 knots during the eclipse.
I didn't know.
So that was a last minute correction and prediction, and it's within some tolerance. Of course, there's always a little bit of a window, but this was executed nearly perfectly. I mean, I've gotten subsequent to the flight what was actually flown versus what we actually gave them to do, and the intercept of this was, as you describe, perfectly framed. I design any of these eclipse flights to intercept at a position and in an orientation such that it puts the sun straight out. If you think about it, sort of 90 degrees out the window. So you're looking straight out the window at the sun. You're not looking at some oblique angle. And that was the case for this eclipse. But it was also the case for this eclipse because it was so close to near the end of the path of totality and near local sunset, that in doing that, you're actually looking also in the direction of the motion of approach of the lunar shadow, which is not always the same as looking in the direction of where the sun is in the sky. In this case, they happened because it was near sunset and the geometry of this eclipse to line up. So it gave you simultaneously a perfect view of the onset of totality and of the approach of the moon shadow coming right at you, like you're the bullseye, right? It was not coming at some oblique angle. We're watching it transition from one side to the other. So that gives you a kind of a unique viewing geometry, and also accentuates the darkness in the sky when the umbra hits you. It gives a much darker contrast.
It reminded me of Bugs Bunny when, they draw a black circle on the ground and make a hole, but sometimes they move it and drag it in the cartoon. And here was this black circle, and it was being pulled toward us. And I was like, what is going on? It was so clear. And, of course, totality was getting darker and deeper, the sky colors, until we got to the diamond ring. And the black plate was slipping underneath us, shimmying underneath the plane.
Right, and you guys were up at 37,000 feet, which gives you a really much darker and clearer sky, and you had perfect conditions for it. And as I say, the navigation was spot on. So you actually went quite centrally at mid-eclipse, right through the center of the umbra, which gave you a nice concentric position within the shadow.
There was always a question about the duration. Do you happen to know? I mean, could you possibly know that maybe but based on calculations and what occurred? Because I spoke to Dan McLeod, and no one seems to know.
It was 1 minute and 55.2 seconds.
Wow.
That's what you guys got, which was it's only 3.1 seconds over what a stationary observer would have gotten on the ground, and the reason for that is you were basically flying across the shadow rather than with it. So even though the moon shadow was moving very quickly, the speed of the aircraft didn't really help. You weren't really keeping up. You were going across the shadow, and that was part of this plan. I mean, it was where you were intercepting. And so you can imagine if you intercept, at a completely different place, and you're following in the direction that the moon shadow is moving and able to have the sun out, that's when you can increase the duration of an eclipse, like we're going to be doing in 2019 very extensively. That was not the case here. This was a case where you were moving across the shadow rather than with it. So you didn't gain much over somebody who might have been on the ocean below you, but you had a perfect viewing spot for it.
Right. Okay. Before we go to 2019, let's jump to 2017 and the next Alaska flight. That's something you also prepared. And now, where it's not toward the sunset, the tail end of the path, it's toward the beginning somewhat, and closer to, morning, let's say, after sunrise, but morning. So how did that change in its geometry?
So there was a different consideration for that flight. Alaska Airlines got back to us, and actually, this is sort of the first time this has happened to me in flights. We had done the 2016 flight for you guys, and I would have loved to have been on that. But again, I was happy to be on the ground. I was also committed to be on the ground for 2017. But Alaska contacted us and said, "Hey, we would kind of like to do this again," and they basically allocated an airplane for doing that. We had a lot of discussion about the actual viewing from the aircraft. They originally were talking about doing it over the continental United States, launching from Portland or Seattle and going inland or being near the coast or something. And the issue with that, it was a 737 aircraft, and the altitude of the sun right at the coast of the west coast of the United States was almost 40 degrees above the horizon. It was 39 degrees and change. They wanted to be able to have people comfortably viewing the eclipse, both from the window seat on the sun side of the airplane and accompanied by a partner or row share person with them. So two people could watch at each window. That gets very difficult when you're on an airplane that has windows the size of a 737 and you're talking about the altitude of the sun 40 degrees or higher. And I spoke to them quite a bit, and they got on the airplane and saw for themselves that to really have a comfortable view of the eclipse, they needed to push out to a point where the altitude of the sun was lower in the sky at totality. And we set the limit right at around 25 degrees. And in fact, that's where the intercept point got chosen from. It's like, we want to fly as short a distance as possible because, of course, it was already quite a long flight. I think it was around 5 hours round trip, if I remember. But they wanted to keep the altitude of the sun at a reasonable height for comfortable viewing. And that's how the intercept point was chosen. So that was at a point where flying, and this again was more or less flying across the path rather than along it, not quite as severe as in 2016. But you didn't gain much in the way of totality with that one either. It was 1 minute and 43 seconds from the airplane. At the intercept point, the moon shadow was moving something like 4,000 miles an hour, but you were flying. The aircraft was flying across it. But it gave an absolutely spectacular view of the eclipse and of the approach of the shadow. It was just lined up differently than it was when you saw it out of Hawaii.
Right. So now it would have come from underneath the plane, I suppose, and then leave and then go forward, right? It would be the reverse?
Yeah, well, yes, in a sense, thinking of it that way. I mean, obviously, the moon shadow is moving from the west to the east. The aircraft, in this case, is basically moving from the south to the north as it's viewing the eclipse. So the moon shadow is approaching the sun. If you think about it, it's a morning eclipse is on the east, so it's on one side of the airplane. The shadow is approaching from the other side of the airplane, so it was a different situation than you had.
Right. Okay. All right. Let's go to 2017. Were you involved in any besides the Alaska? Were you involved in any other flight plans? For instance, Southwest supposedly had 5 planes that were intercepting. I don't know if they were officially planned or roughly planned, but
yeah, I didn't work with any other airlines. I gotten word of several airlines. I think Delta was one, and Southwest may have been another, where they were talking about possibly being serendipitously, and there probably were because there's so much air traffic in the United States, but they really weren't optimizing and actually making specific plans as Alaska Airlines did with sort of a dedicated flight to be done. So, some people took their chances and said, oh, this flight may be somewhere within the path of totality at some time during it. But to my knowledge, there were not real optimization and sort of mission requiremements that were put on any of those flights. It was more sort of a serendipitous opportunity.
I see.
I did help out with a number of either private aircraft or charter aircraft, other small charter aircraft where people were doing things. But again, it was a situation where as you went inland across the United States, we're talking about 2017, the altitude of the sun was getting higher and higher and more difficult to see out the windows for most aircraft unless you were the pilot and had a good view out your windscreen, depending upon what kind of aircraft it was. So, the Alaska solution of going out over the Pacific and pushing out towards the west, it was really the right thing to do to enhance visibility.
Let's talk about next year. It's quickly approaching, within 1 year. And there's a flight that just, when I read about it, I fell out of my chair, and I said, "Oh my God, this is a dream thing." And I'll still cross my fingers that there's a way I could potentially go. You never know what opportunities present themselves. But right now, this is something that seems really different from anything you've done, and we're talking about some serious duration next to that of the Concorde in '73 or something. Is that the last flight like that? So tell me about the 2019 flight you've got going.
I will. Let me put it into context since you mentioned a couple of things. It is not completely unique with respect to the things that I've done in the 2010 eclipse, which was also out over the Pacific and the path of totality, such that the lunar velocity was moving relatively slowly from west to east. Excuse me. We launched an aircraft out of Tahiti for that, which was an A319. We were able to keep up with the moon shadow in that case for 9 minutes and 23 seconds. So this is not unique, but it is spectacular opportunity nonetheless. And what we're talking about is a similar sort of intercept, but using a Boeing 787 aircraft 1,100 kilometers north of Easter Island in the Pacific, at about 38,000 feet. And we'll be able to follow the moon shadow for between 8.25 to 9 and a little bit minutes, depending upon what the actual winds aloft actually are. But the statistically average winds that you might expect, we get close to 9 minutes, but you can never really count on winds. So there's a little uncertainty there.
And for those who don't know, the maximum possible duration on Earth for an eclipse is what now?
7 minutes and 32 seconds.
Okay.
And so this is what I call cheating Mother Nature. You had mentioned there was a rather spectacular effort using the Concorde in 1973, which was the engineering model Concorde 001 in its last flight before the others in the fleet went into commercial service. And that aircraft was specially instrumented with additional windows put in the roof and so forth. That's a supersonic aircraft, and it was able to actually outfly the moon shadow. They followed the eclipse for almost 74 minutes across North Africa in 1973, and that's a feat that has never been replicated since then. In 2001, we were actually going to be using the Concorde for an almost hour duration eclipse starting off the west coast of Africa, but then, of course, there was that tragic accident in 2000 that grounded the Concorde fleet, and that was the end of that.
It was already in the planning.
That was in the planning, but that one didn't happen. The second longest duration ever observed using a jet aircraft was not supersonic, but almost. It was back in the 1955 eclipse. They used a jet trainer, U.S. Air Force jet trainer, and they followed the eclipse for a little over 12 minutes. So there have been a few of these flights in history. This is the 2010 one that we did was sort of the first one available to just anybody who could manage to get on board, so to speak. It was a commercial charter, and this is the second commercial charter that's going to be an extreme duration. And again, what I call extreme duration is longer than nature will let you have. So the plan is to launch the flight from Easter Island, and it has to be a Boeing 787 aircraft, which very fortuitously do fly in and out of Easter Island by LATAM Airlines out of Santiago, Chile, so we were able to make that arrangement. And it has to be a 787 because the altitude of the sun is 50 degrees above the horizon at the point where it's going to be maximum, and we can extend it. And there's really no other commercial aircraft with the proper endurance and ETOPS rating and all that sort of thing that you can get to that has windows that are big enough to allow you to view that high up. And I was just on one a few weeks ago, and the windows in the 787 are absolutely amazing. They're 47 centimeters tall. It sounds like a number, but that's a half a meter long. That's in height, and they're tilted inward at 16 degrees at the top. And you can view out those windows up to about 70 degrees or even more. So it's actually that's how we chose that airplane and how we chose the launch point, and it all came together. The whole mission plan was to get as long a duration of the eclipse as we can, and it should be somewhere right around 9 minutes.
And these windows, can you share it with someone? If someone is not sitting next to the window, but in the middle seat, could they lean over and potentially both enjoy it at the same time? Are they that big that could happen?
You could. It is, and some people are planning on doing that, and they got to be really friendly and work things out ahead of time because it's not the height of the window that's the issue; it's the width of the seats. In some cases, it is a commercial airliner. We're not able to get the seats out on this one, and the regular economy seat pitch is 32 inches. And getting people side by side and lined up, you do have to look up, and you're still looking up at 50 degrees, even though the window allows that. So there's a little bit of contortion. Now, some people are planning on sharing by sort of time sharing rather than window sharing. Watching for part of the eclipse and then switching off.
Flipping in the middle, right? Okay.
Who gets second contact, who gets third contact, kind of thing.
Yes.
But another consideration is that, like on all commercial aircraft, the spacing, the cadence of the windows is out of phase with the spacing of the seats, which actually varies a bit. So some rows actually have access to two windows, where some rows have access to only one window. So if people have a partner that they're traveling with or want to observe with or just simply want to share, they can use a row, and they have booked rows for this flight that have either access to more than one window, a window and a half or two windows rather than a single window. And then that gives you a little bit more flexibility, two people sort of side by side rather than trying to just share one window.
Yeah, I'm just trying to think how somebody, perhaps can get on it affordably, because some people may be of a budget, and maybe if they have friends and such, even if they had three seats and shared it, it's quite possible because we have this most likely this 8-minute duration. It's going to happen, and they could do switching and looking and seeing it, and because you're buying the whole row, right? And
yeah, you're basically buying a whole row from across the whole aircraft. I mean, for doing any eclipse observations of this sort in commercial aircraft, the resource is the window. It's not the seats. You really don't think in terms of seats. You need to think in terms of window or windows. And so, if you have a window, you got sort of the cost is like 9 across, unfortunately, because normally you charter an airplane. I don't know if you normally charter an airplane, but when an airplane is chartered, you fill it up. And in this case, you're using just a small part of that capacity to pay for the airplane.
And this airplane's exceptionally smooth, if I recall. Is it the Dreamliner?
It's the Dreamliner, yeah, the 787. It's a dash 9 we're using, Dreamliner.
I took one from Paris to JFK, and it's got those two giant Rolls-Royce engines. I'd never seen anything so big. And I just remember that whether you're in the back of the plane or the front of the plane, it's just really quiet, calm flying. The vibration is low.
Yeah, I just flew one a few weeks ago going from Madrid to Frankfurt on the way up to the Solar Eclipse Conference in Belgium. And it was actually my first time flying on the airplane itself. And the part of this was as an inspection for the charter that we're doing. But it was a remarkably smooth, comfortable flight. I mean, it was quiet, and just from that perspective, which is not an eclipse perspective, it's a pretty neat airplane. It really is.
Would that help in terms of vibration, like people setting up maybe tripods or taping their cameras, that type of thing? Does that help at all in eclipse photography, let's say?
Well, it might. The uncertainties that you do run into and you should plan against are not sort of you do have the normal engine vibration that gets transmitted through windows if you have your cameras mounted on suction cup or whatever. So it's good to use vibration reduction lenses. They actually can damp out a lot of that. And the low frequency stuff is the stuff that can be a problem if you run into turbulence or something like that. But you can get above the cloud top certainly. But convective cumulonimbus at those latitudes can still happen, and you need to get higher above it, or you would locate to a different spot. There's a fair amount of flexibility with a small change in the duration of totality. If you got to move a couple of 100 kilometers or so because there are cloud tops that might be convective and giving you some turbulence. So, there's a bunch of contingencies in the planning for weather and things like that. But you want to try to avoid those situations. I'm not saying they're common, they're not, but they can happen. So we're cognizant of that.
Are there other flight plans in the works from the area for this eclipse?
So there's two that I'm aware of, and I've actually done the planning for both. One of them is another commercial flight, which is being offered through Sky and Telescope, which is actually launching out of Santiago, Chile, starting out of the path of totality. And it's going to be basically going not a long distance off the coast. They will get somewhere between about 2 minutes and 55 seconds, and about a little less than 3.5 minutes, depending upon where they finally intercept. There's sort of a variety of intercepts that they can possibly do. They're actually targeting for a range of between 2 minutes and 56 seconds and 3 minutes and 16 seconds. And that would be something like a couple of hour total duration flight out of Santiago and then back again. So it's not this extreme long duration 9-minute eclipse. It's more like a 3-minute totality, a little bit longer than you would get from the ground, but it would get you above the risk of weather. Right. There's a third flight which is planning, which is not really a commercial flight. It's being organized through a consortium called the Chile-California Council, which actually is it's a council that advises the Chilean and Californian governments on beneficial activities in science and education. It's an education outreach program, and they were looking to do an eclipse flight as part of the work that they do, particularly for students and others, a lot involved from Chile. Eduardo Bendek, who's an astronomer out at NASA Ames Research Center, is actually involved in that. He's a council member and one of the promoters of the flight organization, and as I said, I've done the flight planning for them, and that actually launches from La Serena, so it launches from within the path of totality, and they're going to observe right over the coast. They're just taking off from La Serena, going up, going to observe it, and come back down again. But it's not a for sale flight. It's an education outreach flight that's being planned, and Eduardo's not doing it wearing his NASA hat. He's wearing it using he's a Chilean national and using his Chile hat on that one.
Okay. Oh, sounds great.
So those are the three I know about, and I keep putting out queries to anybody, if there are other flights in the planning, simply so we can coordinate, make sure that we're sharing airspace expeditiously, and make sure we're not getting in each other's way. And all. There's a lot of open sky out there, but there are natural places that people might target for. So it's always good to know in advance if there's other flights happening.
And it seems, first indications are that this eclipse may be quite popular, being after the 2017 eclipse, and how many people in the United States got to see their first share of totality, and now have this crave, this real need to get more. It's always a shorthanded on that first eclipse. Oh my God, it just left, where's more? And you've got to patiently wait for the next one, and we've had a series of partial eclipses in 2018. So 2019, I'm noticing like La Serena accommodations are filling up, and in small areas in Argentina, it's been very difficult. However, I booked my ticket to Santiago, Chile on the 330-day out rule, where you can get it. So I got it that exact day, and I'm returning on the 3rd right now, but I can always change that. The point is, I got my ticket, and hopefully it was at a decent fare. It was just they're floating around $1,000, between $900 and such round trip, and I was able to get one at $1,000. So I'm going to Santiago. At least that's set, and then from there take it where I go. Because you could either fly to Argentina or drive to La Serena. There's lots of options. I don't want people to be discouraged that they have to take a tour, and tours could be quite absorbent. People love tours; they love to go on the tour and be catered and such, and they can afford it. But maybe somebody wants to see it who just doesn't have that kind of money, but would willing to save a little bit just to get out there and do it, and do it for under a couple of $1,000 is possible if you really.
I agree. I mean, the motivation for me for doing a flight for this eclipse, and I do actually sort of pick and choose which ones I put effort into organizing flights for, is the availability of getting up to about a 9-minute duration eclipse if you do the flight. On the other hand, if you want to observe from the ground, it's a very good eclipse to do. I mean, I agree that there always seems to be this, well, I shouldn't say always, but episodic outbreak of new generation of eclipse chasers when you have an eclipse that's observed extremely well and by a lot of people, like 2017 was across the United States. So a lot of people got exposed to their first eclipse and were looking, hey, when's the next one? And indeed, as a tourist destination, Santiago it's not the eclipse isn't in Santiago, but it's a 5-hour ride up the coast on a good road to get to La Serena or inland to the valleys, and it's logistically not really a challenge. And cost is not crazy on that, and so there's a good opportunity for ground-based observations, as long as the weather holds. So I expect there would be a lot of people in Chile. The next eclipse after that, the 2020 eclipse, is also Chile and Argentina. And the eclipse that follows that one in 2023 is basically visible only from the Antarctic and the South Ocean there. And so there's going to be, I'm looking into flight now, and so there'll be a flight that would be launched also from Chile or Argentina, either Ushuaia or Punta Arenas.
Wow.
And so there's going to be, 3 eclipses kind of in a row that one way or another either initiate from South America in Chile and Argentina or observe from Chile and Argentina. So a lot of folks who live there are going to get lots of experience with eclipses.
Yes, exactly. No, you're here for the eclipse. You're here for that'd be happening every year. And that's something I now also really dream to do, is to either go to Antarctica or fly above it. I don't know how much that counts, but that's a continent where I have not been to, and just to have that experience, to see a totality from a polar region like that, and I would be.
And I think I said 2023. I misspoke. I meant 2021, of course.
2021.
Just to correct
yes,
that.
Yes.
And it is challenging, this particular one, trying to be inland. There is the Union Glacier Camp, which is very close to the limit line. They get about 44 seconds. And, this is a privately run camp that you can access from Ushuaia. It's quite expensive. They take people down for doing things in the Antarctic. And I do believe that they're teaming with somebody to figure out what we're doing in an eclipse package, but it's an extremely expensive one. People often point to the Riskaya Station, which is on the coast, without realizing it was officially closed and abandoned in place in 1991. So even though it shows up on maps when you look at it on the internet, it's not an operating facility. And the only other place that the eclipse crosses land where there's any sort of logistical support that might be available is not in the Antarctic itself, but is in the South Orkney Islands. And the weather situation there, Coronation Island, actually, the southern limit crosses over Coronation Island, and then as you go closer to Laurie Island, you get about a 1 minute and 8 second maximum. But the weather situation there is really pretty horrible. I mean, I can quote you the weather statistics, but if ever there was an eclipse that was looking to be done by air from, not necessarily we're going to get a really long duration or we're going to get a particular orientation of the shadow, but rather just the logistics involved in getting there. This is one as a 2021 eclipse.
And so these things should be put into consideration for those who want to see another eclipse, because I know a lot of people are opting out of this 2019 eclipse because it's lower and the chances and the weather. They have the usual reasons as to why they may not go. So they're definitely going to go in 2020. But if you have just that and the other and anything, and then our Antarctica, we really have a long stretch. And then really, when is the next total that could be really easily accessible, let's say, into closer to the United States or Europe? When is that? I don't even have it fresh in my mind. I mean, I know we have 2024 in the United States, but is there one before that?
Well, it depends on what you mean by easily accessible, I suppose. I consider the one that is in Northwest Australia coming up in 2023 fairly accessible. And you can fly into Darwin, and you do need to rent a caravan or a appropriate vehicle and do the coast drive, but it's a beautiful coastal drive, and there's a lot to see along the way. And get up near Exmouth, and that one, other than a very long flight to Darwin, Australia, which is a long way to go, logistically is very doable.
How long is that drive from Darwin to that remote little tip there that it crosses?
You would want to do it, if you were trying to push it, you would want to do at least 1 or 2 overnights. But it's a beautiful piece of coast. I mean,
wow.
I wouldn't, just for myself, I wouldn't go all that way and just start tooling out of Darwin and trying to make miles as fast as I can. I'd want to stop and see things along the way.
And that's an eclipse where pretty much everyone will go to the same place. It's sort of like an island on its own.
In Australia, it's actually a tip of land that sort of juts out. There's it crosses over an island called Barrow Island, which is off the coast, which would be an interesting place. Except it has two strikes against it. One, it's a protected ecological preserve and almost impossible to get a permit to get onto. And believe it or not, even though I just described it as that, it's a major oil shipping facility for one of the major oil companies, and so it's it's a difficult place to get to
Yes.
for that reason. And there's no real advantage of it being on the island as there is to being on the coast itself. So
Yeah. That's
I think
great.
there's going to be a lot of eclipse chasers are going to be crowded into a very I'm saying
Yes,
crowded.
I
but
see that. When we're looking, because it's looking at it in the Pacific Ocean for so long, and I think it's near what's those islands toward the beginning of the path? It's not, but they're not in the path of totality. But they look near, but they're probably not that near at all. I think they're French islands, maybe at the beginning, at the sunrise point. But
Yeah, no, it misses
yeah,
totality
see, so
completely.
right, it's not
Yep.
even worth it because you have to go out to sea. So Australia
Right.
is really the place.
So, but you talk about ease of accessibility. I don't know if you just mean in
Yeah.
terms of proximity, but the 2020 eclipse, just like the 2019 eclipse back down in Argentina,
Yeah.
is actually quite easily accessible.
I'm trying to think that what are the considerations of those? Let's say, I guess those from the United States. What's in their mind to which eclipse they're going to choose? I believe in going to all of them because you don't know which one you're going to see. So, but they can't afford it, and then you're the one that you do choose. Then it could be bad weather, and then you miss the other one. So there's all that. But if you go to all of them, you're going to see one. You're going to see an eclipse. It's going to happen. So, but people don't always have that, so they choose. So, like, they're skipping. Why are they skipping 2019 but going to 2020? Because it's higher in the sky. Is that why?
Well, it is 72 degrees up. The duration of totality is about 2 minutes and 9 seconds or so, pretty much across the entire path across South America. It doesn't really change the duration. So the duration of totality is similar to what the west coast of the United States got in 2017. There's a pretty good weather shot along a large part of the path, and there is a road network that for several hundreds of kilometers actually maintains within center line, and
Yeah.
doesn't quite parallel it, but you have a lot of running room.
Right.
You get in advance on any weather situation, and you can pretty much stay ahead of it. So, I mean, there are large stretches where there's not a lot there, but the road network is there, and you have that sort of contingency. That's a little more difficult in 2019. You've got a lot. I mean, if you needed to go westward, needed to go eastward over the mountains, for example, you just can't really do that.
No, you can't. And you can't even do it legally with the car rentals and such. They don't want you to go to Argentina from Chile, from what I'm hearing from others who have reconnoitered. But yes,
Now,
I
did provide at this recent eclipse conference a map. I mean, just a simple one that identified in detail airfields across Argentina. So, for example, if the weather was really bad in Chile, around La Serena in particular, with a light aircraft, presuming that you have all the right paperwork for entering Argentina, there's half a dozen airfields in the path of totality that you could relocate. And I'm not talking about a long, expensive observe from the air. I'm talking about a targeted charter to relocate into an airfield that's in the path of totality that obviates the logistical problems of trying to make a drive that would be almost impossible to
So you
do.
fly right over the Andes and just go over to Argentina. Is that what
Yeah, hold your breath as you hit 13,000 feet. But no, it is doable. A relocation flight is doable, and part of that is consideration. I mean, it unquestionably adds cost, but do you buy yourself eclipse insurance of some sort or the other? Whether it's in 2020, planning on being able to drive plus or minus a few hundred miles or kilometers in either direction, or longer. I mean, lots of people in the United States in 2017 would just, I'll drive as I need it. I'll drive 48 hours to get where I'm going to go.
Right. Which is what I had to do in 2017. I had to drive and to mobile, and it wasn't the first time where I needed to do that. I did that in Aruba, actually. I went from one side of the island, back to the other side, back again, just to go originally where I was to see the eclipse. And they ended up, everyone saw it there, but it gets hectic sometimes with the weather that day, and mobility is a great thing. That's why I felt 2017 was a given eclipse, even though I leave Carbondale, and I had worked with them for 2 years to be there and be part of the stadium celebrations, but the weather forecast was not good for me, and I felt, well, everybody's okay, you're there, you can stay there, I'm gonna go, and because it was a given, it was 100% clear skies, really, out in Tennessee. If it just
Yeah.
it was so, and 2024, I know many people are going to Mexico because they go for the weather, but I think that our interstates, even though they're not lined up with the path of totality, could give us some breathing room to move about.
Yeah, I mean, you're asking about, which is the next eclipse for people to see in the United States. Obviously, 2024 is the one that everybody's focused on. It's really going up, northward from Texas, actually coming up from Mexico, northward through Texas, and then bending over and going up through Maine. The further north you go, statistically, the higher the probability of cloud. So in the United States and Texas is probably your best shot, but it does actually get considerably better as you hit around Durango, Mexico, even to the coast near Mazatlan. We have 4.5 minutes of totality. So it's longer duration and actually much better chance of clear skies.
Mhm.
The clear sky probability is better than 80% around Durango or at the coast. So.
Okay.
It is a good reason for people to go to Mexico,
Yeah.
although
Yeah.
it's very easy. A lot of people, just like this one, are going to be living in or near the path of totality and going, well, why do I really need to make a drive to Mexico when I can just go in my backyard if they're so lucky? So.
Well, we'll see if there's an eclipse task force that I was on, like in 2017. See if there's another one, and then in that case, I will be part of the United States and do that at least, and try to work it there for people of the United States to see this, because there's nothing better than to have them engage in outreach. And I think we were very successful, despite statistics saying some people didn't go. The point is that everyone knows what eclipse is, and I think people are just touching on, what's a partial, what's a total, more so than they ever have been before, at least in the recent generations, not since '79, and that really was a northwest eclipse. It wouldn't be till the early '70s that it was here on the East Coast, and it's where the major populations are, and that's a long time ago, 30, nearly almost 50 years ago from
Yeah,
early
well,
70s.
47 as I know well because that was my first total eclipse. It was
Oh,
the
okay.
1970 eclipse.
1970,
And
yeah.
that was the day that my eclipse chasing was born, was in 1970. But it actually there was a whole new generation of eclipse chasers that were born on that day, and I think that happened in 2017 as well.
Yes.
But
Yes, yes. Anyway, well, Dr. Glenn Schneider, an absolute pleasure to talk to you on all these details about the upcoming flights and what has happened and all the planning you're doing. And I know you've been so busy at this time working on proposals with the Hubble Space Telescope and your research.
yeah, well, I got in on Friday, so
You got
that's
it.
a little
Okay,
bit
so
of
that's
sigh
great.
of relief.
Congratulations on
Right
that.
with the
That's
deadline.
great. And again, tomorrow is the anniversary of our eclipse, so I want to have this out
That's right.
and try to post this. I'll be busy editing tonight, getting this stuff out because I think people will have that need and have that remembrance because we just don't have an eclipse tomorrow. As some people, even some children think, are we going to see the eclipse tomorrow? I mean, it was so cute when they said that to me, and I said, no, it's not tomorrow. It doesn't come every year the same year, but they are going to remember it tomorrow, and what it was, and all their memories will be coming up on Facebook, and such like that. They pop up
Oh,
to
yeah.
see your memories. So
Yeah.
tomorrow it will be in their minds, no matter what the news is. And just to give anything to share, little tokens. It's a Christmas or a celebration of an eclipse, the following year, and that will gradually fade, but we'll be getting that much closer to 2024.
Right, the memory will be there for that. Yeah.
But I want to thank you so much for this time.
Thank you, Mike. I appreciate it.
Absolute
Yeah.
pleasure talking to you on this. Okay, thank you.
All right.